Today is lesson 3.7 and we're graphing absolute value functions. Now, hopefully you all remember absolute value. All right, the absolute value of any number is what? Is positive. Thank you. The absolute value of any number is positive. Okay, so when we're graphing absolute value functions today, an absolute value function is a function that contains an absolute value expression. So how do you know it's an absolute value function? It's going to have an absolute value expression in it. All right, the essential question today that we're going to answer by the end: how do the values of a, h, and k affect the graph of the absolute value function g of x equals a times the absolute value of x minus h plus k? All right, so we're going to take a couple of our lessons and we're going to combine them. We're going to graph these functions by creating an x and a y chart. And what values have we learned to use when we create our own x and y chart?
-1, 0, and 1.
Very good. -1, 0, and 1. So we're going to do that to graph these functions. Then we're going to be comparing them to the parent function. So that's where transformations are making their way into this lesson. So we're going to take some things we've learned in this 3.4 to 3.7 and we're going to put them into this lesson. Now, the vertex. The vertex is the point where the graph changes direction. So look at the sketch. All right. The only reason that this is in your notes is I want you to know when you are graphing an absolute value function, what should it look like? What is the shape that we're looking at right now? Guys, what is that shape right there on the board? It's a what?
A V.
It's a V. Okay? When we graph linear functions, what did the graph look like? When we were graphing linear functions last week.
I don't know.
I want you to just stop and think for a minute. When we graphed lines that were in standard form or we graphed lines that were in slope-intercept form, what did those graphs look like? It's linear. What are the first four letters in the word linear spell? A line. So the graphs last week were lines. Okay? You should be able to look at a graph and say, that represents a linear function. This represents a absolute value function. So I just want you to know an absolute value function is V-shaped. Ms. Johnson, how can I remember that? What does the word value start with? A V. So the absolute value function has a V-shaped graph. All right, now the vertex. Back to the vertex. The vertex is the point where the graph changes direction. So if this is my graph right here and it comes down to this point, this very lowest point, that is where it changes direction and it goes back up. That is what creates my V-shaped. Okay, so the vertex is where the line changes direction. All right, now example number 1 says graph the parent function. And the reason we're doing this as its own problem is because in example 2, we're asked to compare to the parent function. All right, we're asked. So let's just go ahead, graph the parent function. That way you can keep looking back at it to see if you can figure out the transformations. So create an X and Y chart. This should be very simple. We're going to use the values. We already decided -1, 0, and 1. All right, our parent function is f of x is equal to the absolute value of x. So we're going to plug those values into that function. And of course, we're going to get our y values. All right, so the f of x is equal to the absolute value of -1. F of x is equal to the absolute value of 0. And f of x is equal to the absolute value of 1. All right, now when I ask this question, I should hear many, many voices answering me. What is the absolute value of -1?
Y.
Very good. That's my first y value. What's the absolute value of 0?
0.
Very good. And what is the absolute value of +1?
1.
1. Awesome. So I have created 3 ordered pairs. What are my ordered pairs? -1, -1, 1. What's my next ordered pair? 0, 0. And my third ordered pair? 1, 1. Now, let's graph it. How do I graph the ordered pair -1, 1? Loza, how do I graph -1, 1? Okay, give me a direction. Right, left, up, down. Left to negative 1.
And then down 1. Or up 1.
Up to positive 1. Good. All right. What about 0, 0? Jaden, how do I graph 0, 0?
You don't go anywhere.
Don't go anywhere. I plot a point right here in the center of my coordinate plane. And Layla, 1, 1. How do I graph that?
Right 1, up 1.
Very good. Right 1, up 1. Now, we have to remember, it's an absolute value function, so our shape should be a V. Okay? Be careful. Don't make a U shape. That's a parabola. That's something totally different. This is an absolute value problem, so this is a straight line to the vertex. Then it changes direction, and it's a straight line up. Okay? And we put arrows on both ends. So that is our parent function. The vertex is right there at 0, 0. Now remember, we're going to compare our new functions with this parent function. So let's move to example number 2. It says graph the function. So that's where we're going to start. Again, let's create an X and a Y chart. And what are our X values that we're going to use? Class. Very good. Negative 1, 0, and 1 are 3 favorite numbers. Is it okay that I'm writing the function as y equals the absolute value of x minus 1?
Yes.
Yes, because we know that h of x and y are interchangeable. And then, of course, our last column is just going to be our y values. All right, let's plug it in. We have y equals the absolute value of negative 1 minus 1. Y equals the absolute value of 0 minus 1. And y equals the absolute value of 1 minus 1. Now, which part of this function are we going to have to figure out first, Tristan? Because we have the absolute value and then we have subtraction. So which part are we going to have to do first? Nope. The absolute value. Very good. We got to do the absolute value portion first. It's a symbol of inclusion. It's like a parenthesis. We would have to do the parentheses first. So we have to do the absolute value first. So Tristan, what is the absolute value of negative 1? 1. And what is 1 minus 1? 0. So my first y value is 0. All right, Malcolm, what's the absolute value of 0? And 0 minus 1? Negative 1. Daniel, what's the absolute value of 1?
1.
Okay, and what's 1 minus 1?
0.
0. Very good. So we have created, again, 3 ordered pairs. Avery, what are my 3 ordered pairs?
Negative 1, 0.
Negative 1, 0.
0, negative 1.
0, negative 1.
And 1, 0.
And 1, 0. So we are going to go and we're going to plot those. We go left to negative 1 and we stay. That's negative 1, 0. For 0, negative 1, JC, what do I do to plot 0, negative 1?
You go to 0.
Okay.
Go down 1.
Very good. I stay in the center at 0 and I go down to negative 1. And Luke, how do I do 1, 0?
You go to the right 1.
Good. And stay there. Perfect. All right. So again, remember, again, this is an absolute value function. So it should be a straight line down to the vertex. Then we change direction and do another straight line. Now, I want you to take your graph and I want you to look back up at your parent function. All right. Remember, the parent function was at 0, 0, negative 1, 1, and 1, 1. So if I were to draw the parent function on the same table, and you can if you want, if I was to draw the parent function on the same table, is it a little bit easier to tell? Because we're supposed to compare to the parent function. So we're looking for what transformation they used. So someone raise your hand if you think you can tell me. Remember, the parent function is in pink. Our new function is in black. What is the transformation that has taken place on this problem? All right, Travis, what do you think?
Vertical shift down 1 unit.
All right. The only thing I don't like about what you said, we're not using shift. What's the actual word?
Compress.
A vertical, no, get your cheat sheet. A vertical, we crossed out shift yesterday. What's our word?
Transition.
Translation. All right, good. So it's a vertical translation. I'm with you so far. We went down. That's the y-axis. That's vertical. So a vertical translation. All right, keep going.
Down 1 unit.
Down 1 unit or 1 unit down. Either one. I'll take either one, but very, very good. So the vertical translation down 1 unit. Now that's just from looking at the graph, and that's awesome. If you want to go back to the function itself, again, you can tell right here, they subtracted 1 from y. Remember, the parent function was f of x equals the absolute value of x. So how do I know they didn't do something to the x? They didn't go inside the absolute value bars, right? They stayed outside. So they subtracted 1 from my y value. And that is a vertical shift or a vertical translation down, and they moved down 1 unit. Okay, awesome job. Any questions? Nathan.
Well, can you repeat how it's a vertical translation?
All right, it moved down, right? So that's vertical. My y-axis is my vertical axis. So it moved down. How many units or how many spaces down did the vertex? The vertex is very clear. How many spaces down did it move? It moved down 1. So it was a vertical translation down 1 unit. Now, let's talk about the domain and the range. All right, let's talk about the domain and the range. The domain is all of my, Caleb, all of my what values? When I'm talking about domain and range in this chapter, the domain are my what values? My x values. So looking at this graph, is there any restrictions to my domain? If this graph has arrows on the end, meaning it goes off in both directions forever and ever and ever, is there any place where my x values start and any place where they stop? No. So my domain for an absolute value function is all real numbers. All right, so when it's an absolute value function that I've graphed, my domain is all real numbers. That graph goes off in both directions, infinity. So it's all real numbers. But my range is my what values, Blake? They are my y values. So looking at this graph, and remember, we're looking at the black one, all right? The pink one is our parent. The black one is our new, okay? So is there a place where my range starts and a direction that it goes?
Yeah.
What's the lowest y value on this graph?
0?
No, look at the black. You're looking at the black one.
That,
You're right. What is it?
0?
No. You started to say negative something.
-1?
-1. So the question is, Blake, are my y values, are they greater than -1 or are they smaller? If I look at that graph and it opens up, they're greater. So my range is y is greater than or equal to -1. So my domain is going to be all real numbers. My range has a definite stipulation. It's the lowest at -1, and then all my y values are above that. All right, now I want you to take a minute, and I want you, with the people at your table, I want you to work letter B. I want you to set up your X and Y chart. I want you to graph it, and then I want you to compare it to the parent function. Let's create our X and Y chart. What were the values that you used for your X and Y chart? Good. I got my X. I got my Y column. And we use -1, 0, and 1. Okay? So Y equals -3. Now, I had this question. This was a good question. -3 and then an absolute value bar with an X. What am I doing to -3 in the absolute value? Travis?
You're going to take the absolute value and then you multiply.
I'm going to multiply. Very good. Because I have a -3 and an absolute value bar with nothing between them. That is multiplication. So, very good. Let's plug these in. Y equals -3 times the absolute value of 1. Y equals -3 times the absolute value of 0. And y equals -3 times the absolute value of 1. So, what is the absolute value of -1? And what is -3 times 1? Good. What's the absolute value of 0?
0.
What is 0 times -3?
0.
Awesome. What's the absolute value of 1?
1.
And what is -3 times 1?
-3.
Very good. So, Nate, what were your 3 ordered pairs?
My three, -1, -3,
Okay.
0, 0,
Okay.
1, -3.
How many of you got the right ordered pairs? Beautiful job. Now, let's graph them. -1, -3. We go left to -1 and then up or down? Down to -3. 0, 0. We stay right in the middle. And 1, -3. I go right to 1 and then where? Down to -3. So I draw my line to the vertex. It changes directions. Make sure it looks like a V. If my graph looks like anything other than a V, I've done something wrong. Now, the parent function. Look back up at your parent function, or you can draw it. It was negative 1, 1, 0, 0, and 1, 1. So my parent function looks like this. All right? Now, someone raise your hand and tell me, what did you guys come up with for transformations? All right, Amelia. Okay, you got to talk a little louder. All right, they said a vertical stretch. A vertical stretch by a factor of what? Okay, so let's talk about that. Does anybody disagree with what they've said? I like almost everything you guys said. I agree that it is a vertical stretch, and you hopefully, just by looking at it, the pink graph, the parent graph, is definitely wider than the black graph. Okay, so it definitely is a vertical stretch. We also can tell that because, again, they have multiplied the y value. The 3 is outside of the absolute value bar, so they multiplied by the y value, which makes it vertical. A is greater than 1, which makes it a stretch. Okay, but here's the question. Is the factor negative 3 or is the factor just 3? All right, the factor is just 3 because the negative tells me something else. The negative tells me about a different type of transformation. So this one is right. You guys were almost right, but it was a factor of 3. What does the negative tell me? All right, let's go back to or look at the graph. The pink graph is opening up, the black graph is opening down. So what happened to it? Okay, we're close. I hear the word mirror, but we don't call it a mirror. It's a reflection, right? And it's a reflection in what axis? Come on, guys. The graph, the parent function is opening up. The black one flips over. What did it flip over?
Oh, X.
A reflection in the x-axis. Okay, now again, how can we know that? If we just went back to the function, did they change the sign of the y? Or did they change the sign of the x? Did they go in the absolute value bar and did they change the sign of the x?
So it's 2.
Okay, hold on. I'm asking a question. Did they, yes or no, did they go in the absolute value bar and change the sign of the x?
No.
No. They stayed outside, which means they changed the y value, which means they reflected over the x-axis. So they did 2 things. They reflected a reflection in the x-axis and a vertical stretch by a factor of 3. All right? Any questions? Good. Now, let's figure out the domain and let's figure out the range. What would the domain of this graph be? Domain. Who's brave enough to give me my domain? Deslin, how about you? Are there any restrictions to my x values on this absolute value chart? Do the lines keep going in both directions, on and on forever? So what is my domain? All real numbers. Perfect. When your line keeps going off in both directions forever and ever, there's no limit to what x could be. So it's all real numbers. But it's a V shape. So there is restrictions on my range. Okay, range is what set of values? Y. All right, and for this one, my graph is opening down. Remember, we're looking at the black graph. My graph is opening down. So what is the highest that my y is going to be?
0.
Look at that high point. It's 0. So the question is y greater than or equal to 0, or are they all less than or equal to 0? Less than or equal to 0. So that is my domain and my range. And that is lesson 3.7.